Welcome to Power Electronics lecture. In the last few sessions we have already covered the DC-DC converter. So before going to start new unit, we will discuss some numerical problem on the basis of chopper. So this is the problem 1 on the basis of step-up chopper. So step-up chopper is used to deliver load voltage of 400 volt from a 220 volt DC source. If the blocking period of thyristor is 60 microseconds, then determine the required pulse width. For step-up chopper, we have the formula we have discussed in the last class. V naught is equal to Vs 1 by 1 minus alpha. And given quantity we have load voltage means output voltage 400 volt, supply voltage 220 volt. If the blocking period of the thyristor means T off is 60 microseconds, we already know that alpha is equal to T on by T, and we can write T on plus T off. So V naught is equal to Vs T on plus T off by T off. So known quantity we have put in this equation and we get the turn on time T on. So after this solving, T on is equal to 49.09 microseconds. Determine the required pulse width. This is the pulse width required for the time for 49.09 microseconds. Now the problem 2. A step-up chopper has a supply voltage of 250 volt while the output voltage is 400 volt. If the total time period of the chopper is 100 microseconds, determine the number 1 pulse width of output voltage. Number 2, if the pulse width is required or pulse width is reduced to 1/3 for the constant frequency operation, find the output voltage. A step-up chopper, we have formula V naught equal to Vs by 1 minus alpha. Given quantity we have V naught output voltage 400 volt, supply voltage 250 volt, total time period of the chopper T is equal to 100 microseconds. So known quantity we have put in this equation and we get the alpha. Alpha is equal to 0.375, and we know that alpha is equal to T on by T, and T is given. So we will calculate the T on. So T on is equal to 37.5 microseconds and T off is equal to 62.5 microseconds. So our T is justified. Total time T off is 62.5 microseconds and T on is 37.5 microseconds. Now case 2. If the pulse width is reduced to 1/3 for the constant frequency operation. Constant frequency operations means our total time period is constant and T on is different. So new T on, our T on is 37.5 microsecond. We have reduced up to 1/3 and we will get the T on new. So this is 12.5 microseconds. New T off time 87.5 microseconds, because this 100 is constant. Okay. Now new alpha is equal to T on by T, so 0.125. Now we can calculate the new output voltage V naught E naught. Okay, so this is we get 285.75. That means initially for alpha is equal to 0.375, we are getting the output voltage 400, and we have reduced the T on. Then T on reduced means our output voltage will get reduced. So this is the problem 2. Now problem 3. In a step down chopper, the input voltage being 230 volt DC, the load voltage is 150 volt. If the chopping frequency is 4 kilohertz, find the on and off period of the thyristor in each cycles. For step down chopper, we have formula V naught equal to Vs alpha. Known quantity is Vs equal to 230 volt, V naught is equal to 150. Chopping frequency 4 kilohertz means total time period is T is equal to 1 by F means 250 microseconds. So Vs T1 by T, we can write 1 by T is equal to F. So V naught Vs T on T off, T on and F. So we will calculate the turn on time. This is 163 microseconds and T off is equal to this. Another problem we have, input to step up chopper is 200 volt. The output required is 600 volt. If the conducting time of the thyristor is 200 microseconds, compute the chopping frequency. If the pulse width is half for constant frequency operation, find the new output voltage. So we have V is equal to 200 volt, turn on time 200 microsecond, and VDC output voltage is 600 volt. So we have formula, the last numerical we have discussed, VDC is equal to VT by T minus T on. After solving this, we will get the T is equal to 300 microseconds and chopping frequency is equal to F equal to 1 by T. The chopping frequency is 3.33 kilohertz. Now the case 2, pulse width is half. Pulse width is half means T on is given 200 microseconds. Now this is half means 100 microseconds for constant frequency operation means our F is constants means T is equal to constant 3 microseconds. So new output voltage is 200 this, and we will get the new output voltage, that is 300 volt. So there are many problems in the textbooks like PS Bimra, MS Rashid, MD Singhs on the chopper. So please practice the numerical problems on chopper. Thank you for watching.